So this is the demonstration of our project. This is the culmination of phase 1, 2, and 3. So we'll be showing how it meets all 5 of the functionality points. The first one's user accounts, so we need to show that we're able to sign up. We can sign up with an email that looks like an email. We'll do a first name, a last name, and our password. You see we've made this secure. We have a couple of conditions that a password needs to meet in order to be a good password. It checked it off dynamically as you entered it. And if you don't have any of those fields and you try and sign up, you'll get an error and it tells you what's wrong with it. So we see we met all the fields, so we're going to sign up. And we're taken to the home screen. And we already pre-made a user over here. This one is Liam, this one's ABCD. We're going to show that there is live sharing of multimedia content between the users. So Liam is going to post a question to the class. And we'll see that it showed up on both their screens. Again, we implemented this with sockets, so it's very quick. They can both open into this. If ABC wants to respond back, they're going to respond back, and they can also still share multimedia content. So I'm going to share this and send that through. We'll see that both of them got the response. We see the text. We see that the assignment's here. It's viewable by Liam and also by ABCDEF. And we're also able to vote on it. And you see each user can only vote once. It disables a button. They can revoke their like if they'd like to, but they cannot like more times than that. Next, we'll move on to the messaging, the private messaging and the DMs. So first, we'll have Liam start a conversation with ABCDEF, and he's going to try and start this conversation. He's going to say, "Hello world." So what else would he say? He sends that message through, and we see that ABCDEF can go and see that same message. If they were offline, they'd be able to log in and see this message just fine. And they can also shoot message back. We'll see over here that the conversation lit up gold to let Liam know that he needed to respond back to that conversation. If we go into our classroom, we can start to see the functionality of friending and following users. They're kind of synonymous in this case, but for example, we can have ABCDEF follow Liam, and now we can see that he is a classmate that ABCDEF follows. So if ABC wanted to go to their questions and see questions that are specific to people they follow, he'll see Liam's question. Now, if we notice, we can go and remove Liam from the classmates he follows and go back to this page. Go to people you follow, it's not there anymore. Okay, so we show that the functionality users following other users allows them to filter the questions by that user. That should be all for this functionality. Next, we'll be moving on to the software architecture of the project.
So here we'll be going over the architecture of our application. To start, I'll just do a brief rundown of the different frameworks that we use to build the application up to this point. So first and foremost, the web server framework that we used is called Flask Socket.io. It's sort of a marriage between two individual frameworks, first one being Flask and the second one being Socket.io. Flask is a sort of your traditional web server framework that allows you to expose different routes, serve up files, return data, and so on and so forth. Socket.io, on the other hand, is pretty unique. It's a WebSocket server. It allows you to define message handlers to pass WebSocket messages and allows you to listen in or listen for specific types of messages. It's pretty unique. It's its own protocol, essentially, for WebSocket message passing. Now, Flask Socket.io allows you to create a web server that where you can define routes, as we can see here, such as the root route. It allows you to listen on Socket.io messages, all on one web server and on one port. So it's very powerful. Lets you do a lot of very useful things. Being able to work with both of those frameworks. Now our database is a MySQL database running in a separate container. It's different from the container running the actual web server code. And in order to interface with that database, we use SQL Alchemy. And SQL Alchemy is a Python framework that is a object relational mapping framework, or ORM. And this allows us to define classes or models for the different tables in our database. As you can see here, we have a comment class, and this is reflected in the database as a table called comment. And then each of the columns are the fields that we have defined as a database column. So now, these are very helpful as it allows us to manipulate the database using object-oriented programming. It makes it very easy to insert things to the database, update rows, delete rows, all through object-oriented programming by method calls, and just simply passing these objects into different functions. And we'll see that a bit later on as we sort of dive into the different routes and other functionalities of the application. In terms of front-end work, the frameworks that we used are Bootstrap and jQuery. We can see the Bootstrap here, all of the classes that essentially every element has some sort of class styling, and most of those are from Bootstrap. We did do some of our own styling, but very little of it. For the majority, it was all through the Bootstrap CSS and JavaScript files that they provide in order to have what they make work properly. And this was very helpful in allowing us to make a site that looks very unified and also looks fairly well, in our opinion, in such a short amount of time, and really allowed us to hit the ground running. In order to get the JavaScript functionality up and running much faster, we used jQuery so that we could very easily manipulate the DOM, the document object model, and make AJAX post requests. Also, in the client side, we used Socket.io so that we could actually connect to the web server, to those Socket.io message handlers, and very easily pass messages back and forth. And this allowed us to hit the ground running and sort of avoid the headaches that we might run into if we had to use just bare bones WebSockets. Socket.io was very, very useful. So now that we're actually in the application, let's take a look at each page individually and see how the data is sort of flowing through that piece of the application. So right now I'm on the questions page. And if you notice, I'm at /home. So now when I click between these different pages, I'm still at /home. And the way that this is working is that this HTML that we see here is a combination of our homepage HTML, which has the header up here, and the questions page in an iframe. And we did this so that we could have sort of a single page application feel to it, so that when the user clicks between different pages, you don't see the entire page load and refresh, only the content here. So when you're clicking and paging around, it's very smooth and seamless. So that's what's going on there. We're just changing the source for the iframe. So the iframe source is actually going to be home/questions. We can see what's going on in that in our views.py. Yep, so /home will render the template for the login page if the user is not authenticated properly with their token that was passed in along with their request. Home/questions can handle two types of requests, a get or a post request. A get request will return the HTML for that file. And as you can see here, again, we want to authenticate the user. If they're not a valid user, we don't want to let them into the site. So we will reject their request and provide them the login screen so that they can authenticate themselves. Otherwise, we will find the appropriate filter from the query parameter. By default, it's just going to be, it will either be empty, and if it's empty, we'll just get all of the questions in the database and populate the HTML. So as you can see here, we're doing some more SQL Alchemy work to query all the questions. The filter is following. We will get all the questions where the person who posted it is a person that the current user is following. If the filter's me, we'll query the database to get all of the questions that you have posted. And this here will get us a collection of questions by calling .all. Then as we want to populate the HTML, we want to get all the comments for the top question because that's the one that will be displayed on the page. And again, we want to query using SQL Alchemy. As you can see, it makes it very easy to just do sort of a one-line call to query the database. It's very simple and very, very useful. And then at the end of this route or endpoint, we will return the questions.html page. And here, now is a good time to actually talk about the templates used in Flask. So Flask uses the Jinja templating engine, and any template files should live in this templates directory because Flask will look in that directory when you call render template and look for the file that you have specified, questions.html. So if we take a look at questions.html, we can actually see some of the templating engine in action. So first off, we will have the appropriate filter highlighted. So if it's all questions, we will make sure that the active link is the all questions. If it's your own questions, we'll make sure that the active link is my questions. Then for each of the questions that exist in the search, so let's assume it's all the questions, we will put all the questions on that left-hand side bar, as you can see over here. Then we can use the templating engine to fill in the data for the top question with all the comments down below it. So what else can you do on the questions page? We've seen this before. We can post a comment. So hello world, responding to our hello world question. So what this will do is we will post a request to our comments route. So we can see here that we want to post a question to home/questions/question ID /comment. So this will post a new comment to the specific question. And we will package up the, on the front end, we will get the JSON text of, or we will get the text and pass it as JSON, as a multi-part encoded form, because the comments section allows you to upload files as well. So here we're able to get the comment string from that multi-part encoding. as well as getting the list of files in that as well, and saving those into the server in the uploads directory. So at the moment, we don't have any files uploaded. But if I had uploaded a file in that comment, it would be stored in that folder. Actually, I believe it would go to static, as we can see here that we are cut. Good. So now, upon a successful comment post, we will emit that comment to all of the active users that are connected to the site. So here, let's take a look at emit comment. So that is defined in sockethandlers.py. So this is where we have some of our socket.io functionality defined. So emit comment will just broadcast your comment to anyone listening on this comment emit message handler. And we'll provide this JSON payload of the comment ID, the question ID for the question that the comment belongs to, the text, the number of likes, which will be 0 upon comment creation, the links for the attachments, and the person's name who posted the comment. So the front end will listen to this on questions.js. Here we can see some of the, here's one example of the socket handler. But on the comment emit, we can see that it will receive that data, and we parse it, and if that comment is tied to the currently active question, we will add it as a new, we will display it on the UI. So the last bit of functionality or sort of data passing that's going on in this on this page as well is posting questions. So I can post my second question. Post, and so that will make a post request to our home/questions route again. But this time we're going to go into the post section of the handler. So we're able to get the request method from Flask very easily there. And again, we want to verify that the poster is an authenticated user. Then we simply get the question title and the question contents. And that was just what the user provided to us in those text boxes. Then we want to verify that the user actually posted something in both of those boxes. This sort of minimizes people from posting questions that don't have any content to them and sort of spamming the site with empty questions. And again, you can see it's using SQL Alchemy to create this question object and then add it to the database accordingly. And then, since this is something that everyone should see, we want to omit this question. And that again is defined in sockethandlers.py. And emit question we'll just provide the question ID and the title ID, and the question title, and broadcast it to all users. And then, as you saw, that question was then added to our list of questions. Actually, I lied. We have one other route to show off. So clicking on that link will load the next question that you've clicked on. And that is done by going to the home/questions/ID route. And once again, verify the user. And we'll try to find a question with the ID that was provided to us in this path. If it wasn't found, we want to return with a 404 not found error. Otherwise, we want to package up all the JSON for that question, get all the comments for it. So as you can see here, we will be getting the user who posted the question just to get their name and last name so that we can display it on the UI. We'll be getting all the comments for that specific question and just packaging up a nice JSON array of all of those comments so that we can put it onto the UI. And as you can see here, we are just returning a JSON object with all of this data. And that is what will be parsed on the front end to display what was shown in that in sort of the question panel here, as we can see. So we got the poster's ID, the title, the content, and the comments. Since none were there, nothing was displayed. But as you can see here, we were able to get all the comments from before. And if we want to, we can actually see sort of that JSON payload. I can load a question. We could try possibly question 3. Yes, so here we go. That is the current question that we're sitting on the actual website. So we're able to get the title, name, likes, and here's our list of comments as well. And each comment will have its list of attachments. So now I'll just be going over how the data is passed between the front end of the server on the questions or the messages part of the application. So as you can see here, I started a new conversation with Billy Bob. So clicking on a new message and Billy Bob's name will make a post request to our home/comments routes, or conversations, excuse me. We'll make a post to our home, to our /conversation. Here we're going to perform some CRUD operations on comments in the on conversations in the database. Excuse me. So the way that we handle messages in our application is we have a table of conversations. A conversation is just a pairing of 2 IDs of the 2 users who are actually in the conversation. So the owner is the person who created the conversation, and the guest is the person who I invited. So when I clicked on Billy Bob's name, my ID was chosen as the owner ID, and Billy Bob's was chosen as the guest. And then this will map, or the messages table will map to the conversation table, where each message will refer back to the given conversation ID that it is a part of. So in /conversations, we will, if you post, you'll make a brand new conversation. So that'll just create that single row in the conversation table with the conversation object that you can see that we create here. And obviously, like all the other routes, I forgot to mention that we will, again, verify that this person is actually a valid user. Now, if you make a GET request with the specific conversation ID, we want to get that conversation object. Then we're going to get all the messages that belong to that conversation and return that as the payload. And we can see that defined up here. So here we're going to do some joins on the conversation table with the message and account table to get the account IDs for the users who sent the data, or the message, and the messages themselves. And we will add all of this extra data and pass it along to the front end when you ask for those messages. And that is going to be done once you click on sort of a conversation to get all of that data. So by me clicking here, I'm making a request to get all of the messages tied to this specific conversation with Billy Bob. Now, so if upon making that new conversation, actually, that will cause us to call this emit conversation. And what that will do, we can see that functionality defined in roomhandlers.py. So this is where we sort of tried to break out some of the socket.io functionality and sort of keep things modular, at least a little bit in our application. So here what we'll do is we will tell everyone in the, tell all the connected users to refresh their rooms. And upon doing that, we can see in the roomlogic.js, once they get that refresh rooms message, we're going to call join all conversations to then emit this enter rooms message. And upon receiving that message, the server will then take that socket and add it to all of the appropriate rooms. And those rooms are going to be the IDs of the conversations with which that user is a part of. Now, that allows us to broadcast, whenever a message is posted, we're able to broadcast to that specific room, as you can see here. So we'll emit a message and we'll broadcast it to that specific room. And that means that it'll go to all the users that are joined into that room. And this allows us to very easily send it to just those two users who need to get that message. A big privacy concern would be that we just broadcast any message to any socket. That would allow people to snoop and listen in on private, seemingly private conversations. This way, it allows us to send it to those two users specifically, and the only way to join a room is on the server. A JavaScript client can't say, I want to join this specific room. The server handles all that functionality, so it allows us to control what rooms people join. And we only add people to rooms that we find in the, to conversations that we find in the database. Now, if I want to post a message to Billy Bob, sending that message will make a post to our /message route. Whoops, wrong file. So we're going to go to the /message route. So posting here will create a, again, first we want to authenticate the user. But if we're posting, what we'll do is we'll just capture the ID of the conversation that they're posting to, along with the text that the user provided to us. And we'll just create that new message in the database and then emit that message to those users, which we just saw very briefly before. And also to improve usability, we can see here that we have a notifications functionality. So as you can see, I logged in, well, actually you can't see Billy Bob's screen, but I logged in as Billy Bob and I sent a message to myself. And you can see here that on the questions page, we have a notification next to the messages to indicate you have a message waiting. This is done by having the home page also listen in on any message emit socket, WebSocket messages. And then upon seeing that, it won't do any UI manipulation beyond just increasing that counter. So if I send another message, again, we'll just increase that again. So we just have two pages, or two places listening in on messages. This page itself, which will actually display those messages, as well as the rest of the site, and it will notify you if you haven't seen any incoming messages. So the next part of our site is the assignments page. We didn't actually add much functionality to it. This is sort of just a dummy part of the site that we wanted to potentially add functionality to. We unfortunately didn't get around to doing so, but we can still show the route where it lives. That would be at /home/assignments. Each of our pages will be preceded by /home. And again, you can see that we want to verify the user and make sure that they are that they are authenticated. If they are, we'll just simply return that assignments.html, which at the moment has no other server-side functionality other than what you see right here. So let's look at the data being passed to and from our final page, the classroom page, the data that's being passed from that page to the server. So when I click on follow, the front end is going to search through from the button that you clicked on to find the appropriate ID to send. So here we have this div storing Billy Bob's information. And we can see here that it has his ID stored inside, the ID of 2. So making that post request will send that ID to the server. And upon receiving that request, we want to make sure that the person who requested it is actually authenticated. Then we want to double check that the person you want to follow is actually a valid user. So we just take that ID and make sure that they are legitimate and get their account. If you already follow that person, then great, we'll just return a 200 success request and no changes will be made to the server. But if that person that you requested for isn't actually a user on the server, we'll just return a not found to indicate that there was an error. Otherwise, we'll, if you weren't following them before, we'll add that as a new entry to our table to indicate that you, the user, are following the provided ID. Then we'll just, again, return the success with all of Billy Bob's information such that we can, store that or display that in the appropriate column. Now we can also unfollow. As you can see, that removed that from the list of people that you follow. And to do that, we just, again, made a post request to /unfollow, authenticated the user requesting the action, and simply removed the user from the database if they existed. Now, even if the person didn't exist in the database, we're still going to return a success because the database is in the same state regardless of what happens. So it's either the row is either missing before you make that unfollow request, or you remove them, and then after that removal, the database is going to be missing that row. Now, the final piece of data being passed to and from the server and route that we want to take a look at is the logout route. So clicking on logout will, again, route me to, or will, as intended, bring me to /logout. Now, if we take a look at that right here, what we're doing is we're getting the token that the user provided us, and we're going to delete that token from our database. This will invalidate any future use of that token. So if a user tries to say, hey, I have this token, let me in, we'll have no knowledge of it, and we'll just treat them as an invalid user and force them to provide our credentials. Now, what this is not doing is deleting all of the tokens for that user from the database. So if they're logged in another browser, those tokens will still be valid because for some reason they may want to keep their session alive on their home computer while logging out of the library computer, let's say. So that will only log them out of a single session. And then we will provide them with the login page if they wanted to log back in and the logout was a mistake.
Okay, so I'm going to talk about the reflection part of the presentation. So we learned a lot about using containers to deploy our application. So one of our teammates, Sam, faced difficulties in trying to migrate a Docker container from Python 3.6 to Python 3.8, the most current version, that is. In the end, Sam couldn't get it to work, so he had to write code by himself to solve a problem instead of applying an existing Python module. So that was pretty tricky for Sam. Now Liam faced difficulties with the DM task, where in phase 3, where we implement the conversations with tokens as well as sockets, and he found it pretty tricky to implement it, especially the signaling the user that they have a new message was pretty difficult to implement. Now, I personally had never actually developed a website before, so 98% of this course was sort of new to me. I had to learn how to use Socket.io, databases like MySQL, Ajax, frontend, and this was a pretty challenging task, but I got a chance to learn a lot due to this project and work on front end as well as back end, which helped me significantly understand significantly how web development actually works. I was also introduced to some the Docker containers and Docker, and to be honest, it's one of the neatest topics that I've ever learned to implement. And I would always use Socket.io, Flask.io, as well as Docker in my new or my future projects. As a team, we enjoyed using Flask and Socket.io, and we will probably use them again in the future if we ever work together. But if we were to do something differently, we would actually try to implement a better framework, as there were a few bugs that we came across that were a bit difficult to fix due to the framework we had chosen. For example, the bug of uploading a file and the other user who received the file not being able to download it was a pretty interesting bug because it was a very tiny fix, but because of the framework, it was a bit hard to find why this was happening. So I guess we would try to implement something that was better now knowing what causes a bug like this. So yeah, that would be our reflection for this project.